Hello everyone, welcome to the sixth tutorial in our series of AWS Redshift. In this class we are going to see some more DDL commands like one creatable command we have seen in our second last video, that is my fourth class. We have seen the creatable command in detail, so we are not gonna discuss it here, but the other DDL commands which are alter, drop and truncate, I'm going to show you how these work, what are their functionalities and their basic syntaxes and all. So let's get started with our alter command. So what DDL commands stand for is DDL stands for your data definition language. So these are the set of commands which we use to change our table definition basically. So create table can create a new table, alter table can modify a already created table, uh, drop can simply remove the table from our database, and truncate can uh, uh, truncate can like removes all your data from the table. So we'll start with our alter table command. So this is the basic syntax of your alter table command here. So we define it as alter table, then our table name, the table name which we have already created or which is already present in our database, and then we can add a constant into that, like table constant, like unique primary key, foreign key, or and foreign key, like that kind of constants we can uh, add to that table. Also we can drop the constant, we can change the owner of the table, we can rename the table, we can rename one of the column of the table, uh, we can add a new column to the table, and like that kind of functions we can perform using the alter command. So let me show you a few examples how to use the alter command. So I'm going to take my already present creatable script from our fourth class. So this is a creatable script for creation of my class table with five columns, and primary key is defined as serial number. So what I'm going to do here is I'm going to remove this primary key definition from here, and I'm going to create this class table. Since class already exists, so one time we'll drop this class table quickly, and we are going to recreate it. So class table is created. So once the table is there in our DB, we can use alter command to change its definition. So what I'm going to do here is I'm going to set our serial number as primary key again using the alter command. So we'll write alter table, our table name, then I want to add a primary key to it, and my primary key will be if it is a we can define a single column or a group of columns as a primary key. Since it is a single column here, so I'm going to give it serial number here, execute this. Okay, and it shows an error that nullable columns cannot be converted to a primary key. So keep in mind whatever field you are setting up for primary key, those are set to not null. So in our table creation itself, we are going to set it as not null, and now we'll try to define that column as primary key, and as you can see that command ran successfully. So if we go to our Database Explorer now and see the definition of our class table. So it should show serial number as our primary key. So serial number here is our primary key is set to yes. So if we want to create, like if we want to define a foreign key, then simply we need to mention here foreign key, and our key, like if class ID I want to create as foreign key, so class ID, and it will reference my another table I'm considering a dim class, and its class ID. So that way we can change the definition of a column and set it as a foreign key. If we go to the definition of our class table in our Database Explorer, so this is our definition for the table class. So firstly we have our create table, and then our alter command, which add the constraint class primary key with primary key as serial number. So every primary key and foreign key has a is defined by a unique name only. So here it is given class underscore p key. This primary key is given the name class underscore p key. So one more way in which we can alter the table and define a primary key is by alter table or table name and then add a new constraint. Add a new constraint with the constraint name, and then which constraint it is. It is a primary key, and my primary key will be my serial number. So we'll now drop it again and we'll recreate and we'll alter it. So this command is executed successfully. We'll go to our Database Explorer and we're gonna see now what is the name of our primary key in our Database Explorer. So as you can see, instead of giving it any random name, now it is giving it the name which we have defined, like new p key, whatever name we have given here, it assigns that name to that key. Similarly we can do it for foreign key. We can simply give here foreign key and my key here or my column name here, and which table it references to. So it will reference to, suppose, to a new class, and then which column it references to. So that's how you add a new constraint using the alter command. So next let's move on to some other commands. So the constraint, we can drop the constraint. Suppose whatever our this primary key which we have added here, so I want to remove it using the alter command. So I'll simply write here drop constraint and my constraint name, so it is new p key, and it drops that constant from the table. One more thing what we can do is if my constraint is a foreign key, like if that column is used in a separate table, so we can use here restrict and cascade. These two terms will further discuss in our drop table command, where it will be more clear to you. Next thing comes the owner and rename. So what we can do is, using the alter command, we can change the owner of the table. So how we are gonna see all the present users is using this script pg user info table. So simply to select start from pg user info, it is a catalog table, system catalog table, and you can see that rdsdb, it is a default user that Redshift cluster creates, and this is our master user which we have created while creating our cluster. So now what I am going to do is I am going to create a new user quickly here. So the syntax is very simple: create user 001 I am creating here, and its password I am setting to 123456. Okay, so password should contain a character and lowercase and uppercase values. So dogs don't lie $. Hopefully this should work. Okay, so this is working. So I'm going to change my user for class table to this user 001 which we have newly created. So using the same alter table, your table name, then honor to a command we use here, honor to user 001. So the alter table executes successfully. We'll go to our DB Explorer, and if we can see our honor, I don't think we can see here, so let it be. But this honor of this table has been changed. So if you will connect to this database using user 001 here, and try to execute some queries on this class table, so you can do that now. So how we can check whether this table is successfully changed to the owner is, there are many ways, but one thing we are going to quickly do here is we'll try to drop this user. Since I'm using the master user account, so I can create as many users I want, like that. So I'm going to drop this user here. I'll try to drop this user, and it gives an error that it cannot be dropped because the user owns some objects. So since we have given it the privileges of using the class table, so it cannot drop this table. So again I'm going to change my privileges for the class table to my master user, and again we'll try to drop this user, and you can see now this user is dropped successfully. So that's how we change the ownership of one of our table. Then we have our rename to and rename column. Okay, let me get rid of some of the commands here. Okay, so we have our uh, class table already here. So what I want is, I don't want it with the name class, I want it with the name dim class. So enter table, your table name, rename rename to rename to the new table name. So here it will be dim class. So this enter command runs successfully, and if you try to select from class, it will show an error that class does not exist since we have changed its name to our dim class table. One more thing we can do with rename is, we can rename column. Suppose I want to change the name of SCR number to S underscore NO. So that also I can do, but I have to do in dim class now. So we'll quickly run this, and if we see its data, so the column name is S number instead of SCR number previously. So column names also we can change, we can rename the column names here. After that comes our add column command. So if I'm having, like, suppose 5 columns here, I want to add a sixth one. So we'll use enter table my dim class and add the column, which I'll name it new column, and it is a varchar of 10 here, and it can't be null, and it is encode with our LZO encoding. Okay, not null should have a default, so we'll define a default here. So ABCD is the default here, and we'll run it and execute it successfully. So this is how we add a new column to our table, and the similar way as constant, we can drop our table with restrict and cascade. So suppose this new column I want to drop, so what I'm going to do here is, I'm just going to change add column to drop column, and my column name in this class and the column name or the new column is no more there in our table definition. So this is particularly about the whole alter table command. Like, we can add a new constant, we can change the owner of the table, we can rename the table, we can rename the column, we can add more columns, and we can drop a column from the existing table using the alter table command. Now don't worry about restrict and cascade, now we are going to discuss that only. So next comes drop command in our DDL list. So syntax of drop command is very easy. So it is like drop table if exist, the name of the table, and then cascade or restrict. So drop table, the most easy syntax is which is generally used is our drop table and then our table name. So this drops the complete table, it removes that table completely from your database. So if you try to query it, so this table does not exist. One more thing we can do here is drop table if exist. So without this, if I'm trying to execute this command now, so we'll get an error message here. An error occurred when executing the SQL command. This is an error message. So what we can do here is, we can just specify if exists. So I think you are much comfortable with if exist, if not exist in our create table also we have used it. So in drop table we use drop table if exists. So it drops the dim class table only if it exists in our database. If not, then it simply shows a message on the message box, but not an error. So if we execute this, it just shows a warning message that dim class does not exist and will be. So now let's discuss the cascade and restrict terms. So what cascade does is, if my table which I am going to drop is being used in any view or is referenced in any other table, we use cascade to remove all such dependencies. So let me show you with this with an example. So what we are going to do here is we'll create two tables. Okay, so first table I am creating is my class table only. So I'll create this here. Class already exists, so okay, so quickly I'm going to drop that class table, and now I'm going to recreate it. So class table is created, and one more table we are going to create here is my student table with std id, which will be an integer, and class id, which also will be an integer here. So I'm quickly creating one student table. Student also already exists, so I'm going to drop this table, and I'm going to create it here. So student table is created. Now let's just alter this student table and add a foreign key which will be to my class id, and it references my class table's class id. So we have defined this student table. Foreign key class id is a foreign key which references our class id of the class table. So now what happens is, this student table is dependent on our class table. So if we'll try to directly drop this class table, it shows that this object like other objects depend on it, so we can't drop it directly. But if we use a cascade here, so it ignores all these kind of dependencies, and if there are any dependencies, it will remove those foreign keys from the other table. So if we try to drop this with cascade, so it executes successfully. So let's come to our restrict. So restrict is just the uh, opposite of our cascade command. So what it does is, it if there are any dependencies, it will it will not drop it. So it is like our default. If we don't define a restrict here, it is even restrict only, since this is the default value. So that is the basic functioning of your cascade and restrict. The next is our truncate table command, which is having a very easy syntax. So truncate is used to delete all the data present in our table. So firstly, we'll try to insert some data into our class table. So let's see if this table already exists, so yes, it exists, and these are the columns it has. Since the serial number is identity field, so it will be, its values will come automatically. So now all the other field values, I'm going to insert one record into this table, and then we'll run the truncate command and see that all the values get truncated. So insert into this, my class ID is an integer, class description is a varchar, and teacher is also varchar, and room number will be, okay, some screenshot taken, sorry for that. So these values will quickly insert into this table. We see that these values are inserted successfully. Now we'll run the truncate table command. So syntax is truncate table and our table name here. So if we execute this, it says truncate class successful, and if we see the data in this table, so there are no records anymore. So whenever you want to delete all the data in from a table, so you can use truncate command. So there's a basic difference between truncate command and delete command. Since from delete also, as we'll see in our DML commands list, that delete also removes records from a table. But what the basic difference between the two is, the truncate command releases all the unoccupied space at the very same time. But if we remove a record with the delete statement, it releases the unoccupied space after vacuum only. So this is the basic difference between these two. We'll see what the vacuum command is, how to work on delete statement, but for time being, this is our truncate command. So next, let's quickly see the create user command. We have I have demonstrated like how to create a user in this tutorial only. So the basic syntax we are going to discuss here is, so the create user command syntax is like create user, the username, whatever name you want to give here. So like we can give user 001, like that, any name you can give. So like that, any name you can give for your user. Then you set the password for it. So password, and your password here, which should contain uppercase letter, lowercase letter, a digit, and a special character. Also you can give password in the MD5 hash string also. So what it does is, you can generate a MD5 code for your username and password. So suppose my username is user001 here, and my password is God is great exclamation. So you can select the MD5 for it, concatenating your password and your username. So for concatenation you can use double pipe, and it will concatenate the two strings. And the MD5 function is the built-in function in Redshift which gives the MD5 encoded value for the string. So this is my MD5. So what I can do here is, I can create a user with the username user001 and my password, which is instead of a straight character and letters, I am using MD5 hash here. So I'll be using this MD5 encrypted string as a password here. One thing to keep in mind when creating a user with MD5 encryption is that you have to start the password with MD5 here. So only then it will consider this password as a MD5 encrypted password. So I will try to execute this command here, and this user created successfully. So the use of MD5 makes the password storage much more secure, and it is for that purpose only that we use MD5 at most of the places. After that, disable, what disable means is, if instead of giving a password, if I'll just write disable here and we'll create a user 002. So what this disable means is, this user can connect to our Redshift cluster with the predefined IAM role only. There won't be any separate password for this user which is stored in any of our system table. He or she will connect to the cluster using the predefined IAM role ARNs only. So that is the third case. So we can define password in three ways. After that comes the options which we use, like with, and after that whatever option we want to give here. So I'm not going to demonstrate each one of it. I'm just going to tell you what these mean. So there are the options can be create DB, no create DB. So if defined create DB, the created user can create DB in the cluster. By default it is no create DB. If create user keyword or the command is defined after with, then the user can create more users. It has privileges to create more users, and opposite to it, no create user won't allow the user to create more users. Syslog access gives access to the user to access our system tables. If that is restricted, it can't access our system tables. If unrestricted, it can access our system tables. In group defines the group in which we are creating this user. So the groups you can define in your AWS console, and that group you can mention here and create user into a particular group. Valid until defines the time period or the date to which this user will be valid. So for example, we can define here a date here, so that that user will be valid only till that date. After that it won't be able to connect to the DB. And at last we have the connection limit. So this is the concurrency level, like the number of connections a user can make simultaneously in separate windows. He can connect up to 5 connections he can make, or up to 10 connection. We can define that limit here. By default it is like, I think it is 500 connections a user can create simultaneously. So this is all about the create user command here. So one more thing I'm quickly going to demonstrate here is our creating a duplicate table. So previously we have seen that using the create table, our table name, and in this, like like the previous table name, we can create a duplicate table. So one more way to create a table with all the data also, since this like class only copies the definition of this class table to this table name table. So I'll drop this one. But if you want to copy the data as well as the table definition to a new table, so what we can do is we can simply write create table duplicate class as select star from class. So this query copies the definition of our class table and puts it into duplicate class, and also all the data present in our class table and puts it into our duplicate class. But note that it does not copy the not null default uh, definitions. Okay, so for that purpose you can use the like command uh, to copy all these not null and default definitions. But here if you want to copy all the data, you can do it like that also. So this is also a way of duplicating your already existing table. Hopefully these DDL commands are easy to understand and you are able to work on it, and now you are much comfortable working on SQL workbench and on writing some SQL queries. So keep on working, keep on trying, keep on creating new tables, defining their definitions, using everything at least once, so that you will be comfortable with everything. So I'll see you in the next tutorial where we'll discuss the DML commands. Okay, so thanks for watching.